Hi, welcome to Virtual CB1A. This is Miss Rena, and for today's video discussion, we are going to focus on inscribed circle. So, dun sa last na discussion natin, ang itsura ng mga figures na tinakal natin ay mostly triangles inside a circle. Kunyari, perfect yung circle ko. And then, meron siyang triangle sa loob. So, these are circumscribed circle. This time, the other way around naman. We have inscribed circle. So, yung circle naman, yung nasa loob ng triangle. So, we will start with figure 2.5.6, inscribed circle for triangle A, B, C. So, as you can see in the figure, we have here the radius R, which is the line OD. So, lagyan ko siya ng markings dito para nasusundan nyo kung ano yung ina-explain ko. Okay, so let R be the radius of the inscribed circle. So actually, we have three given radii here. We have OD, OF, and OE. So let D, E, and F be the points on segment AB, which is a side of the triangle, BC, and AC, respectively. Now, what is special about points D, F, and E? Okay, so aside from being points on segment AB, which is the side C, segment BC, which is the side A, and segment AC, which is the side B, sila rin ay points on the circle. Okay? And they are actually tangent. So these points are the point of tangency of the circle and the triangle. So sila yung mga points kung saan nag-meet yung side ng triangle at saka point on the circle. When we say tangent nga pala, nakalimutan ko siyang ilagay dun sa basic parts of circles natin before. So when we say tangents, they will only intersect the circle at one point. So say for example, this is line L. And it intersected our circle at point A. So we say that line L is tangent to the circle at point A. So dito naman, side A is tangent to the circle at point E, side B is tangent to the circle at point F, and side C is tangent to the circle at point D. Okay? Now, we have another property for our line segments OD, OF, and OE. So, aside from being tangent to the circle, they are also perpendicular to the sides A, B, and C. So, si OD, ito, this is OD. It is perpendicular to side C or segment AB. Tapos si OE, ito naman siya, it is perpendicular to side A, which is BC. And finally, we have OF, ito siya, it is perpendicular to B, side B, or segment AC. So thus, triangle OAD and triangle OAF are equivalent triangle. So since they are right triangles with the same hypotenuse OA. So if you are going to look closer, congruent tong dalawang triangle na to. Itong isa-shade ko, isang green at saka isang pink. Yan. So these two are actually congruent triangles. Okay? And similarly, ito naman, si OD and OE, since they are both radii of the same circle and they are sharing one side, OB, we can guarantee that this side here, DB or BD, and EB or BE are also congruent. Ganon din dito sa pangatlong set ng triangle. We have OC, which is common to both of them. OF and OE are radii of the same circle, so they are also congruent. Therefore, CE and CF are also congruent. So remember, for triangles, we only need two congruent sides to conclude that the third side is also congruent. Nasusundan ba? Hopefully, nasusundan. So, yun lang yung sinasabi nito. Now, let's have this definition. Angle OAD, burahin ko muna itong mga markings ko. Angle OAD is congruent to angle OAF. Okay? So, CPCTC tayo. Congruent parts of congruent triangles are also congruent. I-explain natin kung ano yung ibig sabihin ng CPCTC. Bakit nangyari yung angle OAD ay congruent kay angle OAF? Drawing ko siya ng bukod dito para hindi nyo nakikita tong ibang parts. Ayan. So, this is R, this is O, this is D. Ito yung radius. Ito naman si F, which is also R. Radius din yan. Since congruent tong dalawang to, they are radii of the same circle. And then, this is point A. Ang sinasabi dito kanina, so, since we know that OF is equal to OD, ano yung reason natin? Radii of the same circle are always congruent. So, congruent na kaagad si OF at saka si OD. Now, we have OA is equal to OA. Ito siya. Nag-share sila sa parehas na side. Ano naman to? We have reflexive property of equality. Right? So, what can we say about these two sides, AF and AD? So, AF is congruent to AD na rin. So, SSS congruence tayo. If you have two sides that are already congruent, the third corresponding sides are also congruent. Okay? So, meron tayong two pairs of sides that are congruent. The third pair of sides are also congruent. Now, dun naman tayo sa OAD tsaka OAF. So, sabi nga natin, CPCTC, corresponding parts of congruent triangles are always congruent. So, ang mga congruent na angles, mga congruent na sides natin are as follows. Yan, lagyan natin sila ng mga markings. So, between this side, OA, and AD, you are going to have the angle OAD. Ano yung counterpart niya dun sa kabilang triangle, OAF? So, we have this common side ulit, yung congruent sa kanya, OA, and the other congruent side to AD, which is AF, and between that, we have OAF. So, the included angle on the two pairs of congruent sides will be OAF and OAD. Therefore, they are congruent. So, that means that OA bisects the angle A. So, si OA Kung congruent pala tong dalawang angle na to, hinahati niya yung angle A. Okay? So, since this is congruent to the other one, isang malaking angle siya na na-bisect, which is angle A. Hinati ni OA si CAB, angle CAB, into two congruent angles. Similarly, ito din, si OB, binisect din niya si angle B, yung CBA o kaya ABC, angle ABC into two congruent parts. And also, si angle C, na-bisect din siya ni segment OC into two congruent parts. Okay? Okay. So for any triangle, the center of its inscribed circle is the intersection of the bisectors of the angles. So this is very helpful when you are trying to construct a circle inside your triangle. So all you have to do is to draw your triangle, i-follow nyo kung ano yung mga dimensions na nire-require ng triangle nyo. If you were given with 3 sides, then draw your triangle accordingly. And then, kung ang given naman sa inyo ay 2 sides with an angles, then draw your triangle accordingly. And then after that, para makita ninyo kung paano nyo i-drawing yung circle sa loob, all you have to do is to bisect all the 3 angles. And then, the point of intersection of the 3 angles will be the center of your circle. So, to make that clearer, we are going to try to construct our own triangle. So, just wait a moment. I will just prepare the tools and then I will be right back once na ready na yung mga tools natin. Okay. Now, our tool here is ready. So, I have here a triangle. So, let's look at the dimensions of the triangle. So, ang dimension niya, this is a 90, 30, 60 triangle. Yan. And the measurements are as follows. We have 6.9 cm, 11.8 cm, and 13.7 cm respectively. Pwede itong palakihin pa. So, magbabago yung dimension niya. So, para masaya, sige. Mga ganito, kalaki. Okay, and then there is a circle inscribed in this triangle. So, this is our circle. Now, we are going to prove or we are going to construct this circle out of scratch. Kunyari, hindi nyo pa, or wala kayong ganitong klase ng ng software that can instantly generate the in-circle or the inscribed circle. So, paano nyo siya gagawin? Using your traditional tools. So, of course, we are going to make use of the protractor. Ayan, si good old protractor natin. Medyo malaki pala masyado yung triangle. So, kailangan natin siyang paliitin para madali nating magamit si protractor. Okay, so drawing tayo ng 90 or drawing tayo ng half ng 90 for our side. Okay. Yan, na-fit ko na siya. I think. Okay, now we are going to draw the center. Para medyo kita siya. Laki-laki ko. Gawin natin siyang red. Yan. Ay, masyado makapal. Makapal. Yan, okay na to. So, half of 90 is, of course, 45, right? So, 45, nandito siya. We are going to draw a line segment from this point. Pangalanan kaya natin siya. A, B, C. From point A to this one, 45. So, drawing tayo. Ayun. So, this is the bisector of angle A. Hinati natin si 90 degrees. Ngayon, punta naman tayo kay angle B. 30 degrees lang siya. So, i-fix natin si protractor kay angle 30. Ayan. I think this is already enough. So, half ng 30, of course, is 15, right? Palakihin natin si protractor para ma-accommodate niya si 15. So, si 15 ay around this portion. Yan, nandito siya. So, drawing tayo ng bisector ni B. Ito siya. Now, punta naman tayo kay C. So, si C ay 60. Bisect natin si 60. Fix natin si triangle. Okay. Now, hati natin si 60. We have 0, 10, 20, 30. So, 30 siya. This is going to be our bisector. So, yan. Nagkaroon na tayo ng point of intersection of all the angle bisectors. And this is, i-pattern natin din sa isa nating triangle from before. This is O. D, E, F. Okay. So, this is center O. This is point D. This is point E. And this is point F. Yan. So, ngayon, drawing na natin yung circle. So, instant ko na lang siya ipapakita. Ay, teka. Wait lang pala. Since we don't have a radius yet, so you have to draw through this point, O, a line perpendicular to AB o kaya to BC o kaya to AF. So, wag nyo kakalimutan na before kayo mag-drawing ng bilog or ng circle, dapat meron muna kayong line perpendicular to point O. Okay, so balik tayo dito. Dito na lang ako magdo-drawing ng perpendicular sa AB. So, dapat, through AB, may dadaan sa kanya sa point O. Ayan. That is 90 degrees. Parang masyadong malaki tong protractor natin. Ang target ko lang ay makapuntahan itong si point O. Yan. So, this is the line segment perpendicular to AB. So, kung magdodrawing tayo ngayon ng circle, so yung measurement nito, syempre, i-fix mo dun sa center. And then, to the radius. If you rotate this, all of the values that it will intersect will be tangent to the triangle. So, lipat muna natin siya dito para hindi siya nakakaabala. Drawing tayo ng circle. Again, dito siya. Medyo liit-liitan ko. Kasi baka lumampas. Yan. So, since you already have the measurement of the radii, just draw your circle. Okay. Yan. So, this is now our circle inscribed inside the triangle ABC. So, again, nag-construct tayo na, or given tayo with the triangle, kinuha natin yung measurement ng mga angles niya, hinati natin yung measurement ng mga angles niya para ma-determine natin kung ano yung center. No, na-determine na natin si center O, nag-drawing tayo ng line perpendicular to one of the sides through point O. So, dapat meron kang perpendicular line through point O to any of the three sides. Pwedeng si side AB, side BC, o kaya side CA. In my case, I preferred side AB kasi yun yung pinaka-convenient. You just need one radius in order for you to draw the inscribed circle. So, radius lang ang kailangan natin once na na-determine mo na si center. Okay? Okay. Now, let's move forward to the next page. Okay. So, we will now use figure 2.5.6 to find the radius R of the inscribed circle. So, paano natin malalaman yung measurement ni inscribed circle? Ikakopy ko lang to dito so that step by step, step, nasusundan nyo yung explanation niya. So, dito lang siya. Dito ko pala siya ilalagay. Tapos, yung figure natin ay dito naman sa kabila. Again, pag may tanong, message lang kayo sa akin. Si Gillard lang nagme-message sa akin. So, I assume Valerie and Joshua, wala kayong problema with the subject. But please, turn in your activities as soon as you can. Para hindi kayo naiipunan. Okay, yan. Ready na tayo. So, we will use this figure, 2.5.6, to find the radius R of the inscribed circle. Since we know that OA bisects A, we see that tangent 1/2 A is equal to R over AD. So, saan to galing? Okay. So, si angle A ay hinati into 2. Ayan. So, si angle A ay hinati into 2. Therefore, this portion here, itong OAD, angle OAD is equal to 1/2 A. Right? So, this is OAD. To make it clearer, ito lang yung focus natin na triangle. Okay? Ito lang. Yan. Disregard nyo muna yung ibang triangle na meron tayo. Dito lang tayo magfo-focus sa naka-highlight ng yellow. Okay. So, tawagin na lang natin siyang 1/2 A. This is Tangent, this will make use of tangent theta since this is our angle na kino-consider and we have the parts AD and OD. Si R, hahanapin natin through AD and half of OAD. So, tangent theta is equal to opposite over the adjacent. If we are going to make use of tangent angle OAD, pwede mo siyang tawagin na tangent 1 half A, and then substitute natin yung opposite niya. Opposite this red angle here is R, and adjacent to it is AD. Okay? So, kung hahanapin natin si R, we have to get rid of AD by using multiplication property of equality. So, tanggal na si AD, we are going to end up with AD tangent 1 half A. To be specific, this is the measurement of AD ha. Baka kasi A times D yung gawin nyo. Angle A times angle D. So, this is AD times tangent 1 half A is equal to R. Okay? So, dito siya galing. This definition here. Yan. Now, meron tayong triangle OAD and OAF na equivalent. Triangles, 'di ba? Equivalent siya dito. Na-discuss na natin 'yan kanina. Ito. Yung green at yellow na 'yan, equivalent 'yan. So, si AD, yung measurement nito ay equal sa measurement nito ni AF. AD is equal to AF. Similarly, kung i-apply natin dun sa dalawa pang congruent na triangle, si DB ay congruent kay EB at si CF ay congruent kay CE. Thus, if we let S be equal to 1 half of A plus B plus C, we see that, okay, so let's substitute the formula. We have S, the perimeter, which is equal to A plus B plus C yun before, di ba? Now, we have, tandaan nyo pa to before sa half of the perimeter, dun sa, tawag mo dito, Heron's triangle. So, A plus B plus C. We have to get rid of 1 half. So, using multiplication property of equality, you will have 2S is equal to A plus B plus C. So, ito yon. Doon yun galing. Ngayon, through addition of segment addition, postulate, kung tandaan nyo pa yon, we have AD, if D is a point between A and B, AD plus DB is equal to AB, right? And then, if C is between B and C, BE plus EC is equal to BC. Ganon din pagdating dito sa third na side. So, dito muna tayo kay side A. So, si side A, meron siyang dalawang segments. We have BE and BC. So, substitute natin yung length ni A, which is BE plus BC. Pwede mo siya isulat as, ito kasi nagsimula siya sa CA. So, if you want, you can start with this one. Since yun yung A natin, medyo confusing yung inilagay niya dito. CE plus EB, yun ang A. Plus, yung B natin, ito siya. So, si B is AF plus FC. Tapos, dun sa dulo, we have AD plus DB. That is for side C. Okay, now, since addition lang naman to, applying PEMDAS, pwedeng tanggalin na lang natin directly yung mga parentheses. So, we can write it as, so ito, hindi ko na siya isusulat ha, madali naman siya sundan dito. AD plus EB plus CE plus EB plus AD plus CE. Saan to galing? Di ba meron tayong mga property that AD is equal to AF? Right? AD is equal to AF. So, lagyan ko ng... Ay, hindi. I-highlight natin. I-highlight natin yung mga pare-parehas ng measurement. So, AD, parehas siya ng value ni AF. Next, si EB, parehas siya ng measurement ni DB. So, EB is the same measurement as DB. And finally, CE, parehas siya ng measurement ni CF. Yan. Or FC. So, tatanggalin na natin yung ibang mga notations na ginagamit natin using substitution property of equality. So, we are going to substitute AD for AF. Next, we are going to substitute EB for DB. And finally, we have CE for FC. So, dito, we will be left with CE plus EB plus, ito ay AD na, plus CE ulit for FC, plus AD is AF. Ay, AD nga pala ang gagamitin. AD pa rin, and then we have here EB. So, lahat sila, dalawang beses na naulit. So, we have 2CE plus, i-pattern natin siya dito, 2AD plus 2EB plus 2CE. Distributive property of equality, nag-factor out tayo. We are going to factor out 2. You will be left with AD plus EB plus CE. Okay? Okay. Now, for the measurement of S, so since we are looking for the value of S lang, ako hindi na kasya. Lipat ako sa susunod na page. Nasusundan pa naman, di ba? Copy ko lang to lahat, tas magbubura ako ng ibang portions. Okay, so since gets nyo na to, burahin ko na siya. So we can have more space. Tapos ito, transfer ko lang siya sa kabila. Liliitin ko lang siya ng konti. And then, pwede ko na ito palakihin ulit. Yan. So, dito, don't forget that this is all equal to 2s. Okay? Now, for the value of s, since we can divide both sides by 2 using multiplication property of equality, you will be left with s is equal to AD plus EB plus CE na lang. Okay? Okay. Now, what do we know about EB and CE? That is equal to segment A. So, pwede mo to gawing AD plus A. Therefore, AD is equal to S minus A. And then, hence, we have R is equal to S minus A times tangent 1/2 A. So, from our formula kanina na, sulat ko ulit, paliliitin ko lang to. Ay, nahagip. So, formula natin earlier is R is equal to AD tangent 1/2 A. So, pwede mo na siyang isulat as R is equal to AD, which is equal to S minus A, substitution property of equality, S minus A times tangent 1/2 A. Ayun, ito na siya. Similar arguments for the angles B and C will give us, so the radius is equal to S minus A times tangent 1/2 A, which is also equal to S minus B tangent 1/2 B at saka S minus C tangent 1/2 C. So, may shortcut ba ulit para mabilis matandaan? Yes. So, for finding the measurement of the radius, S, difference siya ng S and one side, and then, whatever opposite dun sa side na ginamit mo, ito A, di ba A to? Yun din yung gagamitin mo na angle. So, inline lang siya lagi. If you use angle A, then for the difference ng S minus side, dapat S minus A siya. Dito, you chose angle B. So, for the radius, you will use the side opposite it, which is B, for the difference, S minus B. Ganon din dito, C, C. Uniform yan. Okay? So, since na-prove na natin or napakita na natin yung derivation for this one, yung dito, hindi ko na siya mapakita. But for finding the radius, given that you have the area, for any triangle ABC, let S be equal to 1/2 ABC, then the radius R of its inscribed circle is, based sa area ha, K over S, which is equal to the square root of S minus A, S minus B, S minus C over S. Okay? So, end na natin siya dito. Next, doon na tayo sa example. Okay, bye-bye!